For those of you who weren't here yesterday, the reason I'm doing this project is because I had issues myself finding enough role models to look up to when I was touring colleges because I want to be a chemical engineer. That's why engineering is important to me. So when I was touring colleges, I had a little bit of an issue finding role models. So I searched up online and I found out that 13% of engineers in America are women. So that means that there's like 87% of engineers are men. So we wanted to beat that stereotype thinking that only men can be engineers. Women can be engineers too. And I wanted to give you guys the role models and the activities and the fun and the learning about the basics of each engineering. So that's why I decided to do this camp. And I decided to do a camp because for my silver award, I also did a camp for saving the bees and had a really good outcome. So I decided to do this again. So yeah, that's why I decided to do this camp. And since today is day 2, now we are on to the day 2. So I'm going to show you guys a slideshow of all the pictures that you guys posted yesterday. So let me do that really quick. Let me turn off my camera so that I can have you guys see the slideshow better. Or share my screen. Okay, so we've got the day 1 challenges slideshow. So first off, we've got some engineering pictures. This one's pretty nice. It's got a NASA hat on with her safety goggles. We've also got this one with her safety goggles on with a nice love shirt and a thumbs up. These people, they did their, I'm guessing that was the vinegar volcano because it exploded a lot. They looked like they were having fun. And then there's this one. That's a long strand. That's a very long strand of DNA. And I'm guessing that you did the food coloring and it stuck to the DNA. I saw a few people did that and their food dye stuck to the DNA. So that was a cool thing. And this is somebody else's DNA, a little bit shorter, but it looks very sticky and gross. I bet all of you thought the same thing. This is another, I'm guessing, either, I think that looks like the elephant toothpaste, but wow, that expanded a lot. And this is the strawberry DNA. Again, that's a long strand. I tried it out once when I was in biology class in high school. My DNA strand didn't even get past the toothpick. It was just kind of wimpy, but you guys did way better than I did. And you guys are way younger than me. You guys are just great. And then this one, that expanded a lot. I could see that it overflowed into the bucket. And then there's this one, very dark DNA strands. You added a lot of, what's it called? The food coloring, and it did stick to the DNA. We've got this little DNA strand over here. All of yours are way better than the one I did. You guys are great. Oh, this one fell over, but that expanded a lot too. And this is them pouring it in. And that's it falling over again. And then this is Ruby's DNA strand. And it's pink, I see. Okay, so those are all the pictures, but I've got a few videos. So I'll show those too. Oh, oops, let me. Yes, you are more patient than me. I don't think I was that patient when I made mine. Okay, so here's this. Oops. So this is one of the videos that I saw. They were doing, I see the catalyst, I think. So I think that was the elephant toothpaste. But here's her video. And then let me show you guys another video. This one expanded a lot. That flew all the way up. And it just kept going. I seem to see that the baking soda and vinegar volcano happened to expand a lot faster and a lot more came out of that than the toothpaste, but the toothpaste just came slow and steady. It kept on coming. So that's pretty cool too. So this one was the aftermath of it, and it kept bubbling over. It just kept coming. And then Only full screen, this says better. Then there's also this one. This one at the beginning, it didn't go, but then once she stirred it up, it just kept coming. And I saw that at the end, she felt for the exothermic reaction. Did you guys feel, like, did you hover your hand over top of your things to feel for the exothermic reaction, the heat reaction? Oh, you got some on your hand. Did you guys feel the heat reaction? I wasn't able to try it yesterday, but since you guys were, okay, those are the ends of the videos. So you felt the heat. Can you actually brush an elephant's teeth with elephant toothpaste? I'm not sure. I don't think so, because I don't think it would be good for your stomach if it went down your. No, mine was the green bin. Oh yeah, yours was the one that kept overflowing, that little video. Let me turn my camera back on. I'm back. So okay, so I went again and I pulled through the registration. I pulled a few comments from you guys. Olivia S., her mom went to an engineering fair when she was in 6th grade, and that was her introduction to STEM career. And Olivia's mom hopes that my camp will be just as helpful for Olivia. Oh, the elephant toothpaste was fun. That seemed to be a trend. Same with the baking soda and vinegar volcano. That seemed to be really fun. I did baking soda and vinegar a lot when I was a kid. I just kept doing it because I liked how big it exploded. I think the same reaction happens with Coca-Cola and Mentos, but it just keeps going. So we're still getting things ready. In the meantime, since today is Mechanical Engineering Day, I have a t-shirt for that too. We've got this whole mechanism. I think it's a part in a car, I'm pretty sure. If my dad were here, he would be explaining the crap out of it. He loves cars. He has this one car. It's like he races it and he has a lot of fun with it. But that is mechanical engineering. Mechanics, they know a lot about mechanical engineering with different mechanisms and stuff like that. Oh, you reduced your recipe. You broke the recipe in half to reduce the amount of the mess. That works out, yeah. If you do the Mentos and Coke experiment, use Diet Coke. It goes higher out of all the sodas I've done before. Yeah, I think I've tried Coca-Cola versus Diet Coke, and Diet Coke definitely worked a lot better. So, on to a review from yesterday. Let's pull up the core 4 that we went over. By the way, Miriam F. wants to learn about engineering, and this camp is perfect for her. Maybe your sisters are watching. I know some of them. I hope you learn something about engineering at this camp. I think you already have, but hopefully you learn even more. Okay. It's a little weird. I only see half of it, but let's fix that really quick. Shariah, gotcha. Okay, let's share this one more time. Sorry for all the technical difficulties. We're getting through it. Yeah, I could only see half of it too, so we're fixing it really quickly. Let's see if this one works. It's still half. Okay, there we go. So review from yesterday, if you weren't here, or if you were here, just review. Again, the core 4 engineering, civil, mechanical, electrical, and chemical. Those are the 4 that branch off of engineering. And for those, like for civil, there's a bunch that branch off of that, like environmental and ocean and a few other things. And mechanical, aerospace and aeronautical branch off of mechanical. But since they branch off of it, they have a more focused like topic of space and aerospace and aeronautical. And then electrical, a few things branch off of that, and with chemical, a few things branch off of that. So those are the core 4 that all the other engineerings branch off of. And then a quick little review of the engineering words: solutions, engineering, science, math, technology. Again, how engineering fits into STEM while also being a part of STEM and using STEM. weird cycle, but it all works out because engineering uses STEM and STEM uses engineering. So on to the next slide. A review on chemical engineering with reactions, chemicals, raw materials, products, optimization, making things be the best they can be and work the best they can, and manufacturing with large processes and stuff like that. So that's a quick little review on chemical engineering. And again, the review on next slide, the engineering process, how you identify the problem and you explore the possibilities, and then you go into the design, create, try out, improve, little trial and error process. That's why I chose this engineering, because not only do you first start off with identifying the problem and exploring some solutions, then you go into the cycle of trying it out, improving, stuff like that. Oh, Sharia. Sharia rhymes with Princess Leia. Gotcha. Thank you. Okay, on to the next slide. So today, mechanical engineering. Since we've already finished Monday's chemical, we're on to mechanical. So let's do a live poll really quick to check your the live poll option is not here. Another technical difficulty. We're fixing these. We're working on it. Okay. The live poll is not an option right now. Mechanical is your favorite, Emily. Tell us about that. What's your favorite part of mechanical while I'm fixing this technical difficulty? Okay, I see the issue. Caroline, you are current host. Could you promote me to host, because I lost the issue. I lost the poll. Yeah, sorry about that, guys. Technical difficulties, working through it. Let's see, 2 new messages. Mechanical is my favorite building things.
You to the host. See
okay, there we go. Okay, the poll. Let's launch this. How much do you know about mechanical engineering before we get into it? Do you know a lot, a bit, not much, nothing? Oh, Ruby, you make really cool things out of cardboard. Speaking of cardboard, I think we're using cardboard today. Your dad makes car parts, so you know a little bit. Yeah, my cousin, he works at a car shop. He's really good at fixing up cars and stuff like that. Whenever I have an issue with my car, I bring it right over to him. Yes, we are using cardboard today. Yeah. Okay, so 20 out of 26 of you have filled it. My dad is an engineer, so I know a little bit. Okay, so we got 20 out of 26 of you, so 6 more to go. If you're having issues with the poll, just type it in the chat. A lot, a bit, not much, or nothing for how much you know about mechanical. Okay, 2 more to go. Yes, only 1 question for this one. Okay, so let's end the poll. So here's the results. We've got some people know a lot, majority know a bit, some know not much, and a few know nothing. But that's okay, because we are going into mechanical engineering. So let me stop sharing the results. Okay. So we're presenting that really quickly. I like how much you guys are participating in the chat. It's really fun seeing all the things you talk about. My dad is a mechanical engineer and my grandpa flies airplanes, so he's pretty good at fixing them. That's really cool. I think I had a 5th grade teacher whose husband flies airplanes. Okay, so blank screen. Okay, mechanical engineering, day 2. We're finally into it, mechanical engineering. So on to the next slide. So this is another fill in the blank slide. So make sure you got your pencil in front of you and your workbook. If you don't have the workbook, just go along with us. And after the camp, we will have the completed page on the Facebook groups. Okay, so mechanical engineers, they solve problems using their knowledge of math and physics to develop solutions. Mechanical engineers design power using and power producing machines. So a power using machine, it's a machine that uses up power. So for example, a fridge, you plug it into the wall and it uses power to make itself work. But while a power producing machine, like a generator, if your house turns off because the power goes out from a bad storm, you plug in that generator and it produces power so your house can turn back on. So power using, it uses, and power producing, it produces. So mechanical engineers design power using and power producing machines and tools that have movement. They move the gears inside, they twist and stuff, and they move. So it has a lot of movement within it. So some power using machines, like I said, are refrigerators, cars. They use power in order to make themselves work. And factory assembly lines, they use power to work, and including air conditioners, elevators, etc. But some power producing machines are generators, like I said, engines and turbines. So a car is kind of like a hybrid because it uses energy. I mean, it uses power with the battery inside of it to power the air conditioning and stuff like that. But the engine inside of the car produces power to make everything else work at the same time. So a car is kind of like a hybrid of the both, which is kind of cool. But in order to make these tools and machines, where do you find that page? It's page 21 in the workbook. If you don't have it in front of you, we're just going over it right now, and you can have it on the Facebook group for later. We will post it right after the camp, like we did yesterday. So in order to make these tools and machines, mechanical engineers use the same basic machine components that have been used for hundreds or even thousands of years, such as gears, hydraulics, wheels, springs, screws, belts, bearings, and axles. So gears and hydraulics are the two blanks. So again, here is the completed page. So you can check on that really quickly. But remember, power using, it uses it, and power producing, it produces it. And again, it's page 21. And this is the page we'll be posting on the Facebook group if you don't have your workbook in front of you. So are any of you not finished yet? Raise your hand really quickly so I can see if any of you aren't finished before we move on. Okay, yeah. Okay, we got a few. So I'll leave this up for a few more seconds, maybe 30 seconds. Yeah, I find mechanical engineering very fascinating. Speaking of mechanical engineering, can you guys see me while also seeing the screen? No. No. Okay, so some of you can't, some of you can't. So I'll talk about that in a quick second. So we've got one more person who is finishing up their thing. Okay, no more people. So after that, okay, so quit sharing for a quick second. I want to show you guys something really cool that I got. So I spotlighted myself. So my father gave me this from his work. His friend gave it to him. It's this mechanism, which I have no idea what it is, but it just has so many gears. And I think there's like this hydraulic right here. It's got a spring and different gears. Like when this one spins, this one moves. This one just went back into place. I have no idea how that works, but yeah, this is my little cute little show and tell for mechanical engineering. It weighs a few pounds. It's really heavy, but yeah, this is pretty cool. Maybe it came out of a car. I have no idea, but that's pretty cool. So now I'd like to introduce you to Karen Kruger, who's our mechanical engineer. Karen Kruger attended Michigan Technological University, where she earned her bachelor's degree in mechanical and biomedical engineering. She then earned her PhD at the University of Iowa, studying damage and computer modeling of total hip replacements. She is now the director of the Motion Analysis Center at Shriners Hospital for Children. This consists of maintaining equipment for clinical motion analysis for kids with orthopedic disorders and conducting new research in the area. Outside of work, she's a former competitive runner and skier and mom to a 4-year-old girl. That's really cute. So over to Karen. Karen, would you like to expand upon the last slide? Do you think I've told them enough about power using and power producing machines?
I can fill in a little bit. I can't share my video right now. I think you've got it blocked. Doesn't matter too much. But.
Here. I just bumped you to co-host, so see if you can try sharing that again, if that works.
There we go.
Okay, cool.
Well, hi, I'm glad to see everyone here. It's excited to see so many girls into engineering. Just to expand a little bit on mechanical engineering, I know there's been a lot of talk about cars, and that is definitely one of the big areas of what mechanical engineers do, but it's for sure not the only thing. So I think looking kind of broadly at what some of the mechanical engineer concepts are, it's to design, build, test, and analyze. So it can involve seeing a problem in an existing product that you think could be better, or coming up with something totally different. Like with my field in orthopedics, people were having issues with their hips, and the engineering solution ended up being to completely remove it and replace it with a mechanical component. And those have been redesigned over the years to last more and more. So there's definitely a broad variety of different directions that mechanical engineering can take you. I think Ruby's got a presentation. I'll talk more about some of the specifics that I've been involved with.
Thanks for talking about that. That's very interesting. It's cool how you're helping the kids with orthopedic issues. So I wanted to show you guys a cute little thing. We have a crossword puzzle also for mechanical engineering that you can work on your own time or whenever you want. Here's the here's the crossword puzzle. Again, the red words are the keywords, and we put in the hyphens for you in these two different spots. And again, the red words are the words you're using to fill in. And if you're having any issues or you finished it, the answer key is in the bottom left corner for you to scan. So let's discuss. So next slide. What does a mechanical engineer do? What can a mechanical engineer create? And what special things do they know about? So either if you don't have your workbook, you can fill it in the chat, or if you have your workbook, you can write it down and share your answer to that in the chat. They know about how things work. Yeah, they have to know how all of these little mechanisms inside the machines they create work so they can maintain them and create them. Fix cars, airplanes, and more. Yeah, they got to know different mechanisms so they can maintain them. Mechanical engineers build and create things. Yes. They can create machines. Yes. Moving machines, power producing or power using machines. Yeah. They build and design things to solve problems or improve the technology. Yes. They make machines and test them. Yeah. Like with the whole trial and error process in the engineering process. They make things and use power and ones that generate power. Yes. So, Karen, I'd like to ask you a few questions really quickly. So why did you choose mechanical engineering?
I went into this a little bit into the talk that I sent you, so I don't want to give too much away, but I was initially really interested in physical therapy, which is almost a way of, I think, of like applying mechanical engineering to the body, because you've got all of your muscles that are like your power producing material to the body. So I was really interested in that. But then my mom also was like, you're really good at engineering or science and math. You should really look at biomedical and mechanical engineering, which is why I started looking into it. And then really got involved with some of the motion analysis and planning for orthopedic surgery. So it's cool to see how an engineer could impact things in the medical field like that.
That's really cool how you can link something that's non-engineering into an engineering job like what you have here. Do you know any other examples of stuff like that where some type of job that doesn't so much have to do with mechanical engineering or any engineering that might the engineering bring it into a totally different job?
So I feel like it's almost impossible for me now, having been in engineering for so long, to say like there is no engineering involved in that. Because I think of like how roads are designed, that's all civil engineers that have a role in that, like how surgical tools are designed. There's definitely engineers working hand in hand with orthopedic surgeons to design the optimal tools to get the jobs done. Those are two examples I could think of quick off the top of my head, but like wind turbines, I don't know if that's an obvious engineering example, but that'd be kind of a combination of mechanical and environmental engineering.
Yeah, like Emily R just said, engineering is in everything. It's everywhere. Guys, try looking around your room for a second. Find some things that are made by engineers. Like, let me see, something that an engineer made. Well, inside of my mouse that I have here, there's different things inside of it, different mechanisms. It's just a whole machine within this little tiny thing. Any other ideas? Yes, the computer.
Yeah, I saw Hayden said that, and it's like the design of the computer, but also how all those mechanical components fit into it.
Yeah.
And then I know Ruby was trying to work with some of the display things. That's an aspect of human factors engineering, which can kind of be one of the sub branches of mechanical engineering, because you want your displays to be designed so that it's intuitive to people. So that's another thing to think about too.
That's true. And throwing back to chemical engineering day, I feel like I have this whiteboard care cleaner. I feel like chemical engineers help to make that so it can like dissolve or break down the whiteboard marker. I feel like that works too. But what are some ideas of just every day-to-day stuff that mechanical engineers work on other than cars or your orthopedic like movement machines? Like what are different ideas of that?
I'm seeing a lot of good ones popping up in the chat, like a pen with a spring in the side.
Yeah.
Or like, how some of them, like the ink just flows a lot nicer than others. Like it's a combination of probably the chemical to get the different ink properties with the mechanical mechanisms.
Yeah, true. Because there's some like gel
like microwaves and coffee makers. Upgrading older mechanical technologies.
Oh, yeah. Upgrading vacuums to make them work on their own. Yeah, that's a big technological upgrade that we've had in the past 10 years. Everything upgrades over the generations just to make it better and better.
Well, I think I've got a landline phone still, but those are seemingly becoming kind of obsolete because everyone's just got their cell phones now. So that's just an example of the technology evolving to fit current needs.
And what would one thing you would say to someone who would be going into your engineering career?
I'd say just be willing to explore everything that you're interested in. Because I know I said I started wanting to do physical therapy, and I kind of have explored different areas. Like I was in the automotive industry for a little bit and in tractor manufacturing, and I ended up in this pediatric motion analysis, which I honestly didn't even really know was a field until I finished graduate school. I think always be willing to pursue different things that you're interested in, because you never know when you're gonna find the thing that really clicks with you.
Yeah, within engineering, I bet anything you like, you can link to a type of engineering. So just the fact of knowing people like engineering is just really easy to find your little niche in life. Like for me, I like mixing things together, creating chemical reactions, and I found out that chemical engineering works. You liked how machines worked and you liked physical therapy, so you went into your type of job field with helping with orthopedic disorders. So that's really cool. Thanks for your presentation and thanks for answering the questions. I thought it was really helpful for me. Toys
I feel like
too?
I want to
Yeah.
give one more plug too. I know like I see a lot of people that are interested in both engineering and medicine too. And I know you guys are probably a little young to be thinking about this, but an engineering degree is always going to be so useful to you, because I know a lot of people that have gone on to physical therapy school and medical school with an engineering degree, and like engineers are problem solvers, which if you go into medicine, you're also a problem solver. So it really makes for better like doctors and other people you'd work with in the health profession too. So that's kind of another thing to be thinking about as you're deciding where to go.
Yeah. Yeah, that's a really good point. But what is it? I had a thought. I forgot it. Oh no. But so thank you for presenting. And so let's finish up our 3 questions that we just went over. So let's present that again. So let's go to the filled in one to give you a few examples in case anybody didn't have their workbook in front of them. So what does a mechanical engineer do? Well, they solve problems using their knowledge of math and physics to develop solutions. And they design power using and power producing machines that have movement. What can a mechanical engineer create? Well, they can create power using machines like refrigerators, cars, factory assembly lines, air conditioners, and elevators, etc. There's way more than just those few. And same with power producing machines. They have generators, engines, turbines, and way more other than just those few things. And what specific things do they know about? Well, they know about how gears, hydraulics, wheels, springs, screws, belts, bearings, axles, all that stuff. They know how to put them all together into some type of machine. They can build anything with those few things, plus more. Engineers have to be both creative and logical. Yes, that is true. So on to the next thing. So I want to introduce you guys to Abigail Beckman. She is going to be helping with the activity today. Abigail Beckman is a recent high school graduate. She was a Girl Scout for 13 years and recently also completed her Gold Award project titled Monofilament Finish Line Recycling. Growing up, she participated in many STEM and engineering specific camps, and she loves learning about the principles behind different types of engineering, as well as working on different engineering-centered challenges and activities. Abigail is attending Virginia Tech with a major in dairy science. She's another STEM girl. So let's move it over to Abigail.
Hey guys, I'm Abigail, like Ruby said. I'm going to help you guys make a popsicle stick catapult. So I'm going to help you build. Sorry.
Would you like me to present the instructions while you set up your camera angle?
Yeah.
Okay, I'll show them that really quick. So let me present that. So the popsicle stick catapult, the pictures really help for if you're doing it on your own. So it's a 3-pager, but here's a picture of it. And here, I'll show you guys the video here. Can you pull that up really quick? Yeah, so we're gonna show you guys the cute little video that we made for this certain activity. We sped it up and made it look really cute. Pulling that up really quick. Oh yeah, for all of you guys, for the activity, plug in your hot glue guns really quick so that they start to heat up so you can go along with Abigail. So everyone grab your hot glue gun and your parents and plug that in really quick. Okay, so here is the video. Okay, so that was a little preview, and then Abigail is going to bring you guys through a step by step. So are you ready, Abigail?
Yep.
Okay. So I'll be checking the chat for any questions or if you need to slow down or anything, and you just give them that step by step.
All right. So this is the end product that you'll be making, like you saw in the video. So first off, we're going to start out with safety. So you're going to want to make sure that you have a bowl of ice water nearby because we'll be using the hot glue gun, which you don't want to get on yourself. If you do get hot glue on yourself, make sure that you dunk it in the ice water immediately and try to get the hot glue off. Other than that, you're going to need safety goggles or safety glasses or goggles for when you test your catapult. Yeah, so let's get started.
Here, let's give them a quick moment to grab their ice waters and then go over the slides one more time in case they didn't hear you.
All right, so you're going to need a hot glue, a hot glue gun, 18 craft popsicle sticks, 2 rubber bands, one that's thinner and then a thicker rubber band. And then you're going to need a spoon. It's going to be metal or plastic, whatever you have available. And then once you have it completed, you're going to want either a ping pong ball or a cotton ball or even a rolled up piece of paper to test it with. So, yeah. So we're going to explore how to build this. And then once we build it, we're going to figure out ways that we can improve it. So think about ways that you can improve it while you're building it. And just kind of work through the engineering process. There's no wrong way to do this. You can try and rebuild, you can improve, just try to make it better than the original. So does everybody have their ice water nearby and an adult nearby that's completing this? All right. So the first step that you're going to want to do, besides turning your hot glue gun on, is to make a little square out of 4 popsicle sticks. So start with 4 popsicle sticks, kind of lay them out parallel to each other.
Quick question. Somebody put in the chat, my popsicle sticks are thicker. Does that matter?
It should work the same. Yeah, you should be able to make it the same.
And then if we don't have thicker rubber bands, can we use 2 to 3 thin rubber bands? I feel like that would work too.
Yeah, that works.
Yeah.
That's perfect. So when you're using the hot glue guns, try to be quick and precise with your placements because it kind of tends to dry quick. Then do the same with the bottom 2 drops of glue on the bottom, and then put the other popsicle stick down. So now that you have that, that's like your little base to your catapult. You're going to want to take 6 more popsicle sticks and group them into 2 groups of 3. And we're going to glue these together. So put a strip of hot glue on one and then glue 2 of them together like that. And then And then put another strip of glue and glue the 3 together. So it should look like that once you're done. And then you're gonna make another one of those. So you're gonna start out with one, you're gonna put a strip of glue. And try to hold it together for a few seconds to let it dry together so it doesn't come apart.
Okay, so now that she's finished this step, we're gonna take a quick second to let you guys catch up. In a few seconds, I'll ask you to raise your hand. Here, raise your hands right now if you aren't finished, and then lower them when you're done so we know when to move on to the next step. So Abigail, while we're waiting for people to catch up with us, what types of things did you do during your Gold Award?
So for my Gold Award, I created little recycling containers that were installed at a local pond. So for that, I took PVC piping and I kind of designed how I wanted it to work. So I used what's called a elbow piece, which kind of looks like a macaroni noodle almost, on top of a straight piece of pipe. And then I used kind of like a screw bottom so that it could easily be emptied. And so the end goal with that is to help reduce some fishing line and tackle pollution at this local pond.
So you use some of your engineering thoughts.
Exactly.
Yeah. Yeah, I see some of those nearby where you just stick the fishing line on the top and people empty it out every now and then. So it doesn't get in the water, anything eats it.
Yep.
Yeah, it's really helpful for the environment.
Absolutely. It keeps the birds and turtles safe.
So we have 6 more hands raised, so we're not ready to move on to the next step. But also, what types of camps did you go to? You said you went to some engineering camps.
Yep. So there's this one local to Maryland camp called GEMS. It's Gains in Engineering, Mathematics, and Science, I believe. And it's hosted by, one moment. I believe it's the Army Outreach Program. So that's a really fun one that I've done. It's a week-long camp. And we did a lot of similar projects. We did like the catapult. And we got to dissect some organs, as well as collect DNA to test for this certain parasite in bugs, which was pretty neat. Another one I've done is at the U.S. Naval Academy in Annapolis, Maryland. And that one was super fun. We got to play around with robotics and like lenses, how different lenses affect how light focuses, which was pretty neat. Those are the 2 main ones that I've been to. So, yeah.
Someone put in the Q&A for the 3 popsicle sticks, do we glue it yet or not? So far we have the 3 glued together, but not glued to the square yet. Is that correct?
Yep. It's not glued together to the square yet. Once everybody's done, I'll move on.
We've got 2 more hands raised, so let's give it a minute or so, and then we'll move on to the next step. It smells like
Alright.
burning glue. Was Gems through University of Maryland?
No, it was through I believe it was at Hood College, and it was through the US Army Outreach Program, USAOP. And it was actually a paid kind of program. We got a monetary stipend at the end of it. And they have locations all across. They have different locations across the US. So it's not just located in Maryland. If you guys want to look into it.
Yeah, I think we'll put it in the chat in a second in case anybody's interested in that. But I saw in the chat that Lauren, she did Gems last year and her siblings are doing it this year. That's pretty cool. I don't know. I don't remember if I've done any engineering camps. What I usually do is I just grab every loose craft material in my house and I would just make whatever, like if my mom had an issue with anything, I'd try to create something for it. And that was my little thing when I was a kid. I would just create things and create and then do different experiments. I would just leave the kitchen a mess every day during the summer. So we still have 2 more hands raised. So give it a little bit more, but okay, 1 more hand raised.
So what kind of things did you create?
Well, so I think the earliest I remember is when I was around like 5, I got this book where it just had a bunch of different experiments in it, and I would make oobleck like every other day. And I had a bunch of different slimes that I had made, and every time they dry out, I made like 10 different more. So I was really into the experiments more than the building stuff, but I've built a bridge before and I've built a catapult, but I love doing all that types of stuff. But there's no more hand raised, so we can move on to the next step.
All right, sounds great. So like somebody put in the chat before, they guessed the next step correctly. We're going to kind of split it into thirds. So you can kind of, before you glue, you can kind of lay out where you want them to go. So kind of lay it out like that. And then once you have it the way that you want, you're going to put a drop of glue on both sides and then glue it down. And you're going to do this for both sets of 3 popsicle sticks. And don't worry about the strings of glue. You can clean that up later or now. It doesn't impact anything. So is there anybody who needs more time on this, or?
Yeah. Between each step, I think we should just take a moment to raise. Yeah, there's a few people who aren't finished yet, but yeah, guys, between each step, let's just have raise our hands when we're not finished yet, and then lower them. But I mean, between the steps, we can just talk about different STEM stuff because we have a lot to talk about with different things we've done over time. Like what stuff did you build around the house, Abigail, if you built anything as a kid?
Oh, I can't even think. I've definitely done, like you said, the oobleck and the elephant toothpaste. Those were always fun ones. The baking soda and vinegar. volcano.
Speaking of
Else.
baking, I found something out cool. I found out that baking has a lot to do with chemical reactions and stuff. Like the yeast, how they use it as a catalyst. Yeast is also used in making breads and stuff. So that's cool. Like if you like baking, then you probably like chemical engineering.
Yes.
Yeah, there's also
absolutely.
whole degrees you can get in just food science. I
Yeah.
used to have some friends in that field. So
Yeah,
it's kind of fun to take passions to your job.
I'm stuck on one topic. I want to, when I go into college, be a chemical engineer and hopefully minor in culinary arts. So I'm just stuck on the same engineering.
That's a fun one though.
It is. I love baking and cooking and like experimentation within it, trial and error
Absolutely.
with food flavors.
Well, and you
Mara,
could talk about engineering of different tools in the kitchen, like air fryers. I feel like weren't really around a couple of years ago, and now at least
Yeah.
everyone my age has one.
Mara says I made slime with my dad and I really wanted to do the oobleck because you punch it solid and let your hand melt in liquid. Yeah, oobleck is kind of weird. It's like a solid while also being a liquid. It's just kind of tricking you.
Oh, we did a whole bathtub of that this winter to keep my dad occupied. It's a lot of fun. It makes a huge mess, so make sure you have
Yeah.
a proper area for it.
Okay, so no more hands are raised, so we can move on to the next step.
All right, so we're gonna put this aside for the moment, and you're gonna want 6 more popsicle sticks. Yep. So again, you're gonna take only 3 of them, but save those 3 for the next step. And you're gonna make a right triangle out of these. So a right triangle has that like square in the corner, a 90-degree angle. So that's what it's gonna look like. So you're gonna start gluing that down.
Speaking of right angles and stuff, I think with engineering, it's really good to know angles and stuff when creating designs for engineering projects and stuff. A lot of the engineering, well, every engineering with the whole STEM thing, they all use math and trigonometry and stuff, which you won't need to learn until high school. But yeah, they use a lot of math and a lot of angles and everything.
Yeah, my days are pretty much just calculating angles all the time. Thanks with the Olympics going on now too, you can think of like the angles that your hips and your knees and elbows all have to make to perform some of these moves that like the gymnasts and track people are having to make to really perform the best they can athletically.
Yeah. All right,
Oh,
so you're gonna.
Oh yeah, the next step's ready.
Yep. So the next step is the same as this one. So you're gonna make another right triangle. You can lay it out. It's kind of easier to do that way, so you know how it's gonna play out.
Oh gosh, Maddie put in the chat that her sister and her bought a science kit and it came with a lot of cool experiments, but they took all the ingredients and made an accidental explosion. See, this is why parent supervision is very helpful so that you don't make accidental explosions.
It wasn't a big explosion. It was just an explosion.
Very good explanation. Yeah, I have had mishaps within doing different experiments, but what they all have in common is that I didn't have parent supervision. So that's why we're having parent supervision for these experiments and activities. So there's one hand raised, so we won't move on to the next step just yet, but we will soon.
Okay.
Oh, no. Yeah.
Yeah.
That's
All right.
Oh, Isabella said it's not a right triangle, it's a fancy four. Yeah, I can see that.
That's
Yeah,
true. That's true.
it is. So Karen, when you were around their age, did you do any STEM camps or STEM activities all the time? Oh, Maddie T said there is an engineering mod on Minecraft. I'm gonna need to have that. Good thing I have cold water because I just burnt myself a little. Oh no!
Oh, no.
Just remember, if you keep your hand in the cold water, you can minimize the burn. Me too. Okay, let's actually same. If you turn it a little clockwise, it looks like a table. Oh, that's true too. Okay, well, make sure you, after this camp, any of you who accidentally burned yourself with the hot glue guns, make sure to tend to it with some more ice, and hopefully that'll minimize it. But we have one more hand raised, so we aren't ready yet, but we will be soon.
Okay.
Okay, all the hands are down, so we can move on to the next step. But remember, guys, don't rush because we don't want you guys hurting yourselves. We're taking our time so we can get this, do this with minimal error and minimal injuries. Abigail, your camera, your video is
Oh,
not showing at the moment. Oh, there we go. Okay, it's back. So we're ready
Okay.
for the next step.
all right. So this step you're gonna definitely want your parents to help you with. It takes a bit of work. So you're gonna take your pair of scissors and you're gonna work on cutting these little ends off so it actually becomes a triangle. So you're gonna cut along the popsicle stick here and here. And you don't have to cut all the way through the popsicle stick. You can kind of scour it a little bit. I mean, score it. Gosh. And it'll snap easier.
Yeah, and if doing that, if your triangle pops apart from the glue, you can just re-glue it really quickly. So don't worry about anything. And if while you're testing out your catapult, if it breaks in any spots, don't worry. That just means you can add more improvements to it.
Absolutely. Whoa. Okay.
Also, remember to keep those little pieces for later as supports. So don't throw them away just yet.
Yep.
If it doesn't cut, try snapping it or getting your parents to help. These must be strong popsicle sticks because my scissors broke. Oh no, maybe.
Oh my gosh.
Oh gosh. Yeah, just try snapping it, and if you have issues, get your parent to help if they're nearby. Yeah, like Abigail just did, you can just snap it. Doesn't have to look pretty, it's just we're keeping the little pieces for supports to glue on later.
Exactly.
So again, raise your hand if you're not finished so we know when and when not to move on. So while we're waiting, I'll grab a few more comments from the registration. I see that Shelby A loves building things and is a part of the Robotics First Lego League. And Shelby is going to love making the cardboard robotic arm today. Yeah, as one of the challenges, there's a robotic arm that we'll be going over soon. And Cassie Lowry wants to be a robotic engineer. And Abigail's, here's another STEM girl who's going to definitely love the robotic arm. And Emma C, her mom is an engineer, and Emma loves hands-on projects. So lucky for you, we have a few today and each day. Is it okay if my popsicle sticks are small? Yeah, it's totally fine. It's in engineering and when building things, sometimes you have to make scale models or bigger models. So different popsicle sticks are totally fine. You're just making either a smaller, a thicker, or a bigger version of what Abigail's making right now. So we still got 4 more hands raised, but also Kix 11 loves science and doing hands-on experiments, which is pretty cool. I hoped you liked all of the chemical engineering experiments from yesterday. And Lauren E, she's looking for ideas from her science fair experiment, and I think this is the perfect place to find a few. So good thinking, Lauren. Okay, 3 more hands raised. Sanjana, how about you? Have you done any STEM or engineering camps when you were younger?
Yeah, I think somebody might have mentioned it earlier, but I did GEMS when I was in middle school, which they do, I think Fort Detrick runs it, and it's so fun. It's like the summer camp that you do and you apply for it and you learn STEM skills and then you get paid at the end, and it's really cool. And then I also did Science Olympiad in middle school, and then I coached Science Olympiad in high school. I've always done the science fair, and I did a coding summer camp at Georgetown when I was 13, which was really fun.
That's cool. Yeah, I've never really done engineering camps, but that's just because I was on my own little path with all these craft supplies in my basement that I had hands on.
Yeah, so much of it is just like problem solving and being interested in the things around you. And totally, like, me and my sister used to build our Barbies these insane doll houses out of old cereal boxes and scrapbook paper, just because we didn't like the dream house that we had.
I think when I was looking through the registration, someone else builds doll houses for their toys. Who is that? I forget who it was.
I think it's Melanie P. She just raised her hand.
She might not be finished with her activity, but oh, Isabella did an engineering camp before this, but it still isn't as fun as this one. Oh, I'm so glad that you're enjoying this camp. I was hoping that you guys would enjoy it.
Mara G says her mom codes, and that's a really that's something that I think it's cool to bring up. Even if you're an engineer and you're not a computer science major in college, you can totally still learn how to code, and it will be so useful for you. When I was in high school, I took a few classes in coding, and I took another class in coding in my first year of college, and it is so helpful to be able to add like programming to anything that you're building, or if you have data or something like that and you need to format it, if you can code, it's so much easier. So never like try and block yourself into one degree or one path because you think that's your only option. You really can do it all.
Yeah, as long as you're in the engineering field, engineering is everywhere, so there's many different possibilities with it. All you have to know is what your niche is and you'll find something. So there's no more hands raised, so we can move on to the next step.
All right. So now you're going to bring back your base, and you're going to take your 2 triangles. You're going to glue them onto the side of those 3 popsicle sticks. So like that. Okay. And make sure that you are kind of generous with your hot glue on this step so that these supports stay in place. But be careful. Don't be too generous.
Yeah, take your time too so you don't burn yourself.
Okay, and you're gonna do that with both of the triangles. And try to hold it in place for a little while so that it glues as tight as possible to the three popsicle sticks.
Yeah, the reason she did 2 stacks of 3 was so it had more surface area to glue these triangles to the side.
And again,
raise your hand so that we know when to move on. Yeah. Also, if any of you are ahead and finish your step, you can always start prepping things that you'll be launching with your catapult, like rolled up paper or just anything small that'll fit in the spoon. So if you guys are waiting, you can do that while you're waiting. And we've got 4 left, 4 hands raised left.
okay.
Oh no, Hayden said that she was trying to fix one of her triangles. It broke, so she had to do the triangle all over again. Don't worry with that. Yeah, you can just refix it now and note that for later if you are making improvements to it. And if anything breaks throughout the process of testing it, just mark it down and you can have that be one of your improvements. Okay, we have 3 hands left raised. But also, if any of you don't have the supplies in front of you, aren't able to, like if you aren't able to do the experiment right now for any, the activity right now for any reason, then we have everything needed in the workbook, and on the Facebook group, we have the videos for each of the activities and the challenges. So if you aren't able to get to this activity right now, you can just add on to your challenges for later. Remember, post this stuff on the Facebook group. And if you're not on the Facebook group, you can have your parents send it to me and you can be put on the prize wheel for tomorrow. So remember that, and on the slideshow, and we'll show your video. So there's still 3 more hands raised. While I was waiting, I made a gear out of hot glue. Not an actual gear, a decorative one. Nice. Okay, 2 more hands left raised, so we're almost done, almost ready for the next step. Now the 4 is a triangle. Yes.
So Ruby, I don't know if you said it before, but do you know what you want your ultimate like career to be?
Well, so since I was a kid, I've always looked up to my parents a lot with their careers. They're both computer science. They're both majored in computer science, and they worked at the National Institute of Standards and Technologies nearby. And I want to work there. Like NIST, it has a bunch of different careers within that area. So I was thinking of doing chemical engineering there and finding like an internship to do. But I really just like chemical engineering, and wherever it brings me, I think I'll enjoy every job. Like how Jennifer worked with Pepsi and with making Advil capsules and stuff like that. I just think all of that is really cool and inspiring, and I just really don't care where it brings me just within chemical engineering. Um, Emma S says, do we still need the glue gun or should we turn it off? We still need the glue gun. We're just waiting for other people to catch up. We have one more hand raised.
That's really neat. It definitely sounds like you started early on the chemical engineering path with your
Yeah.
oobleck and
Yeah, I've
slime.
noticed over time that I've stuck with all the experimental activities more than the building ones, but I'll be more with building when I find my actual job and I start creating things and mass producing materials using raw materials and stuff. So the hands are all down, so we can move on to the next activity.
Okay, so your next step, you're going to need your one thin rubber band, your spoon, and one popsicle stick. So I'll give you a second to grab those. So during this step, you're going to attach your spoon to your popsicle stick. You're going to do that by wrapping your rubber band a couple times around the spoon and the popsicle stick.
Yeah, if you only have a thick rubber band, I think that'll work. It'll just add more tension, which adds more pressure to I think having a thicker rubber band may make your catapult stronger, so that only does better for you. So yeah, thick rubber band will work.
Yep.
But within, like when we were talking about what I want to do with a job, I was looking at being a chemist for most of the time, and then I noticed how I really like engineering a lot, and I wanted to mix that with chemistry. So then I found out about that there's 2 different careers, like pure chemistry, being a chemist, or chemical engineering. And I like, again, something that didn't so much have a major role of engineering in it. I grabbed a job with chemical engineering instead of chemistry. So yeah, that's a cool thought.
Yeah, absolutely.
And guys, remember to raise your hand if you're not ready yet. I'm catapulting mini marshmallows if I don't eat them all first.
That's definitely a good item to use.
Remember not to use all your marshmallows because you need some of them for Thursday's activity. So don't eat all of them, but you can maybe have a few. So we have one hand raised. Is that it, or are other people still behind? Just make sure you raise your hand if you're not ready yet. Still one more hand raised, so we're almost there. So Abigail, I saw, so we saved the pieces for, engineering is ingenuity. Ingenuity, yes, that is correct. But so the little pieces for supports, where will we be gluing the supports in the next step?
Yep. So in the next step, we're going to be putting them on the side of the triangle over here.
Oh, by the way, all the hands are down so you can move on to doing it.
Okay, well, moving on to the next step, we're going to be taking 2 of those small pieces you cut off in the beginning while making the triangles, and you're going to take them and glue them onto the side of one of them, on the outside side. And that's similar to how we created the stack of 3 popsicle sticks, will increase the surface area for the
Yeah,
step
more
after
space
that.
to glue the spoon part of it to the thing so that it stays on more easily instead of just by a little dot of glue. Oh no, Hayden says I'm so clumsy. I stepped on the cord. My hot glue gun came out and hit it on my leg. No,
Oh,
Hayden, try putting maybe a cold wet towel on your leg. But yeah, remember, take your time and be careful, guys. Remember, we're taking our time with this.
yes. I'm gonna minimize the amount of burns.
And remember, guys, if you're having any issues with these at all, since your parents are nearby, you can have them either prep the glue by putting a dot on or anything. But yeah, just be careful and take your time.
And so you're gonna do the same thing on the outside of the other one as well. So both of them should have the double layer of popsicle sticks.
By the way, guys, for the people who posted on the Facebook group, you can still keep posting, but since you've posted once, your name will stay on the wheel and we're just adding on to it. Is it okay if I use a plastic spoon? Yeah, Abigail is using a plastic spoon. It's
Yep.
just a fancy plastic spoon with metal coating or like chrome coating. So yeah, you can use a fancy spoon or a plastic spoon or a metal spoon, but any type of spoon works. Yeah, remember guys, if your hand isn't raised already, if you're not ready, then put it up really quickly. But we've got 2, 4. Okay. Yeah, we've got a little bit of buildup with the hand, so we'll wait a minute.
Okay.
An invisible spoon? Well, how? I mean, if the invisible.
That would be interesting.
Very interesting.
If you can include a video of that.
Yeah, if you can make that work, definitely put that on the Facebook group. That would be very interesting. Well then, Emily, it's semi-invisible. It's got an outline, but it's still somewhat invisible. But currently somebody just posted on the Facebook group with what they're doing in camp right now. I think it was Mara. Oh, Hayden, you finished your step, or are you finished with the activity? Because you can always save it for later if you want to stop here and tend to your wounds. Okay, you're finished with the step. So we've got 4 more people not finished yet. Oh, now it's 3. So we're getting closer. Okay, now it's 2 hands, so we're getting closer. Yeah, guys, I think we may run a little late again today because it's 11:50. Oh no, the popsicle sticks, small bits are flying. What? They're a magic spoon? Well, maybe a magic spoon will work. Maybe it'll add more force or something because it's magical. Who knows? But yeah, we may run a little bit late today because we've got a few more things to go over after this catapult. So we've still got 2 more hands raised, so we're getting there. We may not get to testing out our catapults live, so we may have to put that as the challenge with I mean, also another thing to post on the Facebook page, you could post launching this and then launching your improvements. So you can do that too. Okay, 1 more hand raised. And again, if your parents don't have Facebook or aren't on the Facebook group, either have them join the Facebook group or have them email me separately with your pictures. And if you're allowed to put your pictures on the slideshow, then I can do that. So if you're on the Facebook group, you can still participate without it. So still 1 more hand raise, we're almost there. The spoon ran away with the fork and the plate over the moon. I think that's some sort of lullaby. Yes, when we cut off the ends of the triangle and the ends of the popsicle sticks, they went flying. Maybe that's why we needed the safety goggles. Yes, that is another reason. But the safety goggles are also there for if when you're launching your pieces of paper or anything, they don't go towards your eye because we don't want you guys messing up your eyes. So still 1 more hand raised. We'll get to the next step fairly soon. We just got another post from Miriam right now of her building her catapult. Yes, you can decorate the catapult afterwards. You can color it, anything, just try not to add any, well, I mean, you can add extra materials, do whatever you want with it. Maybe the decorations will make it more powerful. Who knows? Still 1 more hand, so we'll get to the next step soon. But yeah, whenever the safety goggles are included in the activities, it's either because we're launching something, throwing something, or something is like exploding or like launching or anything. Oh, Florence said, I'm gonna try toy car wheels. So it looks like a medieval catapult. No, what is it called? Well, yeah, medieval, but a portable catapult. It's really like a spin-off of the cannons. Magic buttons, aka the button I stole from my mom's room. Okay, no more hands raised, so we can move on to the next part.
So your next step is to glue the popsicle stick with your spoon on it to your base. So you're going to want to leave enough room on the bottom so that your spoon can go through without hitting this bottom popsicle stick right here. So leave maybe a centimeter.
Maybe a little less so you can wrap that rubber band around it at the very end, that one part. Yeah, around there. Just leave enough room so that it doesn't whack anything and mess up the launch, but don't leave too much room because we're wrapping another rubber band later on.
Okay.
So again, raise your hands and then lower them when you are finished.
So put 2 drops of glue and figure out where you need it to go.
So yeah, it's 11:55, so we're definitely going to be running late because we've got one more presentation and telling you guys about the challenges, doing the Kahoot, and spinning the wheel. So we've got a bit of time to go, but I mean, at least you guys are enjoying it, so that's good. Yes, that is very much true. More time for fun. So we've got two more hands raised, so we're close to getting to the next step. Now one more hand raised. This was a fairly easy step. Now it's one hand raised. So we're getting there. Now it's none, so you can move on to the next step. And another person posted on the Facebook group their current situation with their catapult. I think it was Ruby.
So now you're going to take your final popsicle stick and you're going to kind of create a barrier so your spoon doesn't go all the way through. It has a spot to stop.
Yeah, stopper
Oh.
so it doesn't launch it at the ground.
Yep. So you're going to kind of figure out how long your popsicle stick needs to be to
So trim off the excess.
Yep. And then you're going to cut however much you need off. And you're going to save the excess piece for the next step. And you're going to glue that to the catapult.
It's okay if you did it wrong. That just means there's more room for improving it. And again, it's fine to not get on your first time because that just means you can make it better. And this is your control. So we're just giving you step by step of what to start with, and then you guys can choose what improvements you want to add to it. Like if you want to do a thicker rubber band or double the rubber bands everywhere, add more supports, anything, or even make it bigger. But if you're posting on the Facebook page, remember to tell us a little bit about it. Like, oh, I added more supports in this area, or I decided to use a metal spoon since the plastic spoon didn't hold up well, or I added more rubber bands. We've got one hand raised. Remember to raise your hands if you're not finished, but move on to the next one soon. Emily said she tied her spoon to the wrong. Oh, you tied it on wrong? Well, maybe tying it on wrong actually gave you an upside. Who knows? But this is just the control. So anything you change may make it better. Oh no, you put your spoon on backwards. Well, hopefully you're able to fix it without messing up anything. I feel like if you just twisted the spoon, the rubber band would let it spin around. So maybe that'll work. Florence said, I fully covered the ends of the popsicle stick attached to the end of the plastic spoon, like the rubber on chair legs. It is now more stable. I bet it is with all that coverage. So 2 more hands left until we can move on to the next step. But the reason we're doing this step by step is so that we all start with the same thing so that we can mark which improvements are better versus the original that we all are doing at the same time. So this is considered our control, and the control is like the thing that has no changes. Like whenever you're experimenting or testing out different things, you start with something with no changes so you can mark what happens with the different variables. But Mara says we messed up, so we're back a step. That's okay. So 2 more hands left. Yeah, so since we're already into overtime, we're gonna have you guys do the testing out and the improvements for the challenge. So you can show us, if you're posting it on the Facebook page, you can show us you launching it and showing how the control works, and then launching it after the improvements. And you can either improve it by adding things to the original, or you can just totally rebuild it and add a bunch of supports everywhere. However way you want to improve it, you can do that because there is no right or wrong build when improving. Still 2 more hands. Now there's 1 more hand, so we're getting closer. Still at 1 more hand. We're getting there. Okay, now it's 2 hands. Maybe something messed up or something. But yeah, again, if you're waiting, you can find different things to launch for your challenge. So you can get started on that if you want. Like get a paper, start ripping it apart and making little balls, pulling apart cotton balls, however you want. Even launching the strawberries from yesterday is an option, anything. But if it's messy, remember to do it outside so you don't stain anything if you're launching strawberries or anything. Still 2 more. Has everyone burnt themselves yet? Let's hope these burns are minimal. Very sorry if you have burnt yourself. Oh, you've already launched a piece of paper and it went far. That's good. Hopefully by the end, once we add a little bit more supports because of the instructions, maybe it'll go even farther. But still 2 more hands, so we're getting there. Yeah, after this, I think we have 3 or 4 more steps left, and then that's it. So then we'll move on to the presentation, Kahoot, and prize wheel. Oh no, Hayden's burnt herself 2 times. I'm guessing one was the leg. I did not get how to launch it. Oh, you do not get how to launch it? Well, when you launch it, you would put a paper thing in the spoon and pull the spoon back a little bit, like Abigail's doing right now. So you pull it back like that, and then it just launches. Mini marshmallows are now airborne. I wonder if I can throw it at someone and have them catch it in their mouth. I've decided to make my wheels out of skewers and cardboard circles. Remember to keep some skewers for other activities throughout the week if you're using the supplies. Just remember to recheck the supplies if you're going to grab anything from other activities, so you don't have not enough supplies for an activity. But still 2 more hands. Remember to lower it when you're done so we can move on to the next activity. Still 2 more hands. If you guys with the hands up are having any specialized issues that you need to ask any questions, just remember to ask them so we can help you out. So for those of you who aren't able to stay overtime, sorry about that for us running late. For any of you who have to leave soon, just remember that these instructions and the instruction videos, which will be, I don't know if they're already posted yet, but they will be soon. If they aren't, the instructions and the videos will be on the Facebook page, or if you're not on the Facebook page, I can email them to your parents. So again, 2 more hands raised. It's the same too. So if you guys are having any issues, just ask us for help and we can try to help you the best we can. Oh no, hopefully someone else didn't burn themselves. Let's try to minimize those. That's why we're taking our time and have a parent. Hopefully we all have parent supervision. Not that bad. Well, Emily, just remember the ice bowl's near you so you can dip your finger or whatever it is in there. Still 2 more hands. Are you guys having any issues, or are you just stuck back because something broke? Well, while we're waiting, is there any questions you guys had from when Karen presented or from anything we said so far? If you have any, I'm trying to get my spoon to stay on. Oh no, well maybe that would be something you need to improve for the challenge, who knows? But still 2 more hands. Are we almost prepared for battle? Yes, just a few more steps and then we're ready. We just gotta wait for these last two stragglers so we can make sure we're all on the same page so they don't get caught behind. Now there's a third hand raise. Are people's breaking or is there any like issues? Let me know so that we can help you at all. But just remember, if you're having any issues, remember to join the help desk. Not a lot of people joined to yesterday's help desk. So if you want to join just to talk about the camp or anything, you can join it. Marshmallow Wars. Yes. Don't remember, save a bunch of the marshmallows for the activity that is on Thursday. We need a bunch of them to build something.
Hey, Ruby.
Yeah.
Do you think for like the sake of not going too far over, we should move on to the next step and those who still have their hands raised can join the help desk or?
Yeah, I see the same two people have their hands up. So for time's sake, so we don't go over an entire hour and oh, one more hand left. So the person with their hand up, is it okay if we move on to the next step so that we can try not to go over too much time? I built an ammo holder on it. Oh. Yeah, we need to move on to the next step soon because there's a few more left. And then we've got a presentation from Sanjana and a explanation of the other activities, Kahoot, and then the prize wheel. So, I mean, for time's sake, how about I introduce you guys to Sanjana since she'll be presenting right after this activity. Sanjana is in her second year at Columbia University, where she is studying mechanical engineering and humanitarian design. She's especially passionate about the intersection of engineering and lawmaking with regards to the refugee housing crisis. She realized that she wanted to study STEM back in 2018 when she attended the Intel International Science Fair in Pittsburgh as a finalist. She fell in love with the way research and design can bring the world together. She works at the Smithsonian National Air and Space Museum to introduce visitors of all ages to physics and astronomy, as well as for Peace Tech Lab in Washington, D.C., where she is currently launching a college campus-based initiative to build peace through tech. I think that's pretty inspiring. That's pretty cool. Yeah, I like how she links engineering with her passion of bringing the world together and with lawmaking with regards to the refugee housing crisis. I think that's pretty cool, but she'll go more into depth with that once this activity is finished. But we still have one more hand raised. For you who have the hand raised, is there anything we can help? Because we need to move on to the next step very soon. Or is there an issue with your hand going down? Abigail's dog. I think I'll give it one more minute and then we'll move on to the next step because we got to get going soon. Not trying to go over too long. Okay, I think we should move on to the next step so we can keep going. So
Okay. So your next step is to take that piece that you cut off in the previous step, and you're going to glue it right down here underneath of the spoon onto that bottom popsicle stick. Right underneath of the spoon.
what happens if they have a little bit long of a piece left? Should they break it down a little bit, or is there a specific length it should be?
There's no real specific length. It has to fit the thick rubber band on it a few times. So
Okay.
it shouldn't be too long, maybe about an inch long. And you don't have to cut it off. You can just kind of glue it at about where there's about an inch hanging over on the back. Or you can cut it. Either way works. So and just glue that onto the bottom popsicle stick. And then raise your hands if you're not done, and then put them down when you're done.
Yep. But remember, when improving this catapult, try not to use all the popsicle sticks you have, because I think we've got, well, one of the challenges for today also uses popsicle sticks, which is this grabber that Abigail has. While we're also on Thursday, we are doing one that needs a lot of popsicle sticks. So try not to use all of the ones you have right now on this one, unless you're planning on going back out to get more. So we have one hand raised. So we'll be soon on to the next step. Okay, no more hands raised, so we can move on to the next step.
Okay, so this is pretty much your final step. You're going to connect the bottom of the spoon to the piece that you just put on. So you're going to take your thick rubber band, or I believe somebody had thin rubber bands. You can probably use 2 of them to kind of equate to the thick rubber band. You're just going to wrap it around the front of the spoon, like that. Oh, you can see it. Kind of like that. And then you're going to twist it in the back. And then wrap it around the,
We're losing you a bit at the bottom of the screen.
sorry,
There you go. You're good.
wrap it around the popsicle stick that you just put on. Like that. So now you have your catapult pretty much done.
Yeah, I think that was the last step. So we're going to move on to Sanjana's presentation, and we can do the testing out later, but here's a little example of how to launch it if any of you are confused. And again, this is the control, so if anything messes up or it's not strong enough, then you can always improve it. That went pretty far. So yeah, on to Sanjana. Let me spotlight her really quick. Okay.
Hi guys, I'm Sanjana. Ruby introduced me. It was so nice. I do have a little presentation about who I am as an engineer, how I got interested in it, where I started. So I'll just pull it up. Ruby, can you make sure I have sharing like abilities?
Yeah, let me see. I think I made you a co-host, so that may work.
Okay, perfect.
Yeah, the presentation, I can see it, so that's good.
Okay, cool. So yeah, I'm a mechanical engineer, just like Ruby said. I'm in my second year at Columbia University. And I started in engineering when I was really little through the science fair. The first picture on the top left, that was the first time I looked through a telescope. I think I was either 2 or 3 in that. And then these are science fair projects from junior year when I talked about beaming down solar power from space as an environmental solution. I did a project when I was in elementary school about wind power. There's a few pictures of me with awards that I won. And the bottom right picture is actually my favorite project I've done. I was building a more efficient refugee shelter, and that was in my freshman year of high school. This is a little bit more about that project and how problem solving was really the most important thing in that. You don't have to have amazing math skills or amazing building skills to be an engineer. You just have to have an idea and ambition, and you'll be able to do it. I saw this picture in 2016. It's of the world's largest refugee camp. It is in Kenya. I believed better housing should be provided, so I began work on designing it. The housing at the time was just tents like this. There was some prefabricated shelters, which is like IKEA furniture, basically. Like a shelter would get sent to a camp and you'd have to build it, but they weren't that great. So I wanted to find something that could be really sustainable, but also easily assembled. And this is a virtual model that I made using something called CAD, which is like computer 3D graphic design. There's a lot of really easy CAD tools. CAD is CAD that you can use. And I made this to kind of show how I wanted the shelter to look like when it was still standing. It was important to me that there was a triangle roof so that rain would get washed off into different gutters where it could be collected. And little details like that were super important to me. This video is actually in senior year. I started the project in freshman year, but once I was a senior in high school, I had construction skills that allowed me to build a half-size model of what I would want my refugee shelter to look like. It is really half as tall as it should be and a quarter as big as what it should be. But this is the assembly process. So it would really only take 1 to 3 refugees to build a shelter on their own. It wouldn't take more than 3 hours. And it's pretty easy to build. Like I did it in very quickly. Here's a little bit about my time at Columbia University. If any of you guys are already thinking about going into engineering and you're not sure what that would be like in college, my major is mechanical engineering. Some activities that I'm in are Engineers Without Borders, the Columbia Space Initiative, and the sailing team. Through Engineers Without Borders, my team and I are building a water filtration and distribution system in Morocco. It's so fun. We get to make blueprints. We get to talk with really smart people. And this summer, not the one we're in now, but next summer, we're going to fly out to Morocco and build some concrete tanks to improve our system we have there. In the Columbia Space Initiative, we get to build rockets and launch them. Some parts of the team, the chemical engineers, actually designed some experiments that NASA did launch into space so that our experiments are being done in space, which is so cool. The sailing team, I don't actually know how to sail. I've never sailed before, but I'm always trying to develop my skills, and I thought it would be really cool. And it's also a cool way to learn about aerodynamics. And then some of the classes I'm taking are, in case you guys might think you're interested in this, I do take standard physics. I just took a class in Intro to Electrical Engineering. It was so fun. Even though I'm a mechanical major, you do need to understand the other fields as well. I'm in a mechanics class, and I'm in a computer graphics and design class. But on top of all of that, it's really important that I make time for what I love. I love astronomy. It sometimes does collide with engineering, which is really lucky. But these are some pictures that I took. The first one, I'm not sure if you can see it, but it was the Milky Way. I was in Tanzania on a safari, and the Milky Way was just so clear and visible. So I took a GoPro and I set it up, and it gave me this really cool picture. And the bottom one was in January 2019. there was a lunar eclipse, and I'd never seen one before. And it was like 17 degrees outside. It was like in the middle of the night, but I really wanted to see it. And I thought that as the shadow of the earth went over the moon was going to turn black, but it actually turned this really beautiful red color. And I just love that picture that I got of it. And here's some construction that I do in my free time. It's a little Instagram reel.
Can't hear you.
Closer to engineering, but it's still a fun little thing.
Damn, you look so good. Laying there wearing nothing but my t-shirt. Body's a neighborhood. Wanna drive my lips all around it, cause I'm holding my breath under the wind. You're gonna wake up in my arms, head on my chest, my heart's beating. I can't wait to kiss you each morning. Strawberry sky, cause I get so lost in blueberry eyes.
And yeah, that's like a little video I made. I do a lot of like woodworking, and that's related to engineering, but it's still just something that I'm really passionate about. That's not necessarily like on the path to getting a degree. This is my contact information. If any of you guys like have ever thought about mechanical engineering or going to Columbia or the science fair or anything like that, I would be so happy to help you out, to mentor you. I've done that with a lot of different young women, and it's really inspiring to me. So that's my email, and all of my social media handles are Sanjana4112. And you got this. Like, if you know you want to be an engineer, that's all you need, like passion, ambition, and ideas. So good luck. I'm so proud of you guys for like being in this camp and taking the first step.
Thank you so much, Sanjana, for presenting. It was a really cute presentation. I liked it a lot, and it's really cool how you care a lot about the refugees and how you're able to use your engineering brain to improve the design and make models of it and go through with it. So I thought that was really cool. One second, I gotta spotlight myself. Okay, there we go. So thank you again for that presentation. It was really great. And thank you, Karen, for your earlier presentation. I love that one too. So we're going to go back to Abigail, and she's going to quickly explain the 2 challenges for you. So, okay, there we go. Let me spotlight her.
Yep, so this is the first of the 2 challenges. This is the extendable grabber, which is pretty neat. It extends. So for this one, you need safety glasses, 8 popsicle sticks, 2 large straws, about a 1/4 inch in diameter, and 2 wooden skewers. So this one's pretty simple to build. Do you want me to go over how to build it?
I mean, it looks well, the video is online and on the Facebook group right now, and the instructions are also on the Facebook group. So just give a quick little run through of it in a way.
Yep, so you create
I see the straws are used as little joints where you poke through the skewer to keep them together. And then you just glue on the little grabbers at the end. But the instructions and the videos will be on the Facebook group, so you can further know how to construct them.
Yep, and for this one, you definitely want your parents to help you poke through the straws on the joints. It can be difficult, and if you put too much pressure, it goes through really fast, and I wouldn't want anybody getting hurt. So that's the first one. Is there anything else you want to add in?
Yeah, Anne just asked, do we need the hot glue still? Yeah, you can unplug it right now, all of you, for your hot glue. But yeah, that's the explanation for the grabber. And then was there a third one? Yes, the robotic arm.
So this is my robotic arm. It can be made out of cardstock or cardboard. Both kind of have their advantages and disadvantages. Cardboard will make it sturdier, but cardboard's also kind of harder to cut and cut through. Like you have to poke holes at the end of each, at the joint furthest from the main hand. And it might be kind of hard to do with cardboard, but this is also not as strong. The cardstock's not as strong as cardboard would be. So kind of make it your own and innovate.
Yeah, and if you wanted to start with the cardstock, then move on to the cardboard, you could also do that and make the cardboard an improvement, but do whatever you want. The improvements are not limited to the ones we've already given you. There's just a few examples. Thanks again, Abigail, for doing the step-by-step for the catapults, and we will all be having fun with that tonight, launching marshmallows, strawberries, whatever we can find around the house, including paper and stuff. But on to, one second. There we go. Okay, now I'm spotlighted again. But so on to the Kahoot. Okay, it's 37, so I will start the game. Okay. Day 2, mechanical engineering. Okay. Mechanical engineers design solutions for blank. Yes, many of you got it right. It's all of the above. Okay, let me click next. So I gotta make it a little smaller for me. Oh, Gabby B's in the lead. Okay, there we go. True or false, mechanical engineering is one of the core 4 engineering fields. Yes, it is true. There is civil, mechanical, chemical, and civil, mechanical, chemical, and what's the 4th one? Oh, no? Civil, mechanical, chemical, and electrical. Yeah, that one, electrical, we're going over on Friday. Arabella's in the lead. Which of these are not used in mechanical engineering? So which is the odd man out? Yes, chemical reactions are not used in mechanical engineering. Pulleys, gears, and levers are different things that they use within their machines and mechanisms and stuff. So Arabella's still in the lead. So mechanical engineers use their specialized knowledge of blank to develop solutions. They use their specialized knowledge of physics, which is a mixture of math and science. And chemistry is used for chemical engineering, electricity is for electrical, and then earth science, civil, because they have to like survey the land and make sure that the land is good so they can build on top of it. Maddie's getting up there, but Arabella is still in the lead. So what is an example of a power producing machine? Something that produces power. Yes, an engine produces power. Arabella's still in the lead and Maddie trailing behind. Okay, what is an example of a power using machine? A machine that uses power. Oh no. Okay, so there's a typo in this. Yep. The elevator, just elevator, not DNA. That was a typo. Oops, but the elevator is correct. It uses power in order to work. Oh, Florence is now in the lead. Okay, 7 out of 8. Mechanical engineers are what? Remember, this is just like the one we had yesterday. Yes, all of the above. And technically, inventors is still correct because it's all of the above, so all of them work. But yeah, all of the above. Florence is still in the lead. And the last question, which is not one of the core 4? Yes, aerospace. Aerospace actually branches off of mechanical. Okay. So in 3rd place, we've got Arabella. 2nd place, you juice what at LA. And in 1st place, we got Florence. Okay, good job, guys. You guys did really good. Oh, and the runners up are Gabby and Carissa. So now we finished that. We have to check how much you guys have learned today about mechanical engineering. So let's do that really quick. So now how much do you know about mechanical engineering? A lot, a bit, not much, nothing. So you got half of you guys. 4 more to go. 2 more to go. Give it 2 more seconds. Okay. Here are the results. A lot of you know a lot about mechanical engineering now. One of you don't know, and you don't, not much, but if you want to learn any more about it, again, Sanjana gave you her contact information if you ever want to talk to her. This recording will be on the Facebook group along with the workbook and the activities. So if you want to learn more, you've got the materials for it, along with the website that I'll be launching sometime after camp. So like after this week camp is over. So on to final slides. So let me share those really quick. When we get those shared. So onto the slide of today's challenge. Okay, the green. So we just did the poll and we spun the wheel. So here's today's challenge. So try making improvements by thinking like an engineer. So you can improve your popsicle stick catapult, which is on page 24 through 26. You can create and improve your extending grabber, which is on page 27. You can create and improve your cardboard robotic arm on page 28. And remember, if you are able to, you can post a video or picture on the Facebook group, and we will be putting them in a slideshow for tomorrow. And if you have any issues, or if you just want to stop by, the help desk is from 5 p.m. to 6 p.m. Eastern Standard Time if you want to stop by or ask questions. So next part of the promise, or the, what's it called? I think it's a promise, but act like an engineer. Ask like an engineer. Raise your hand in class. Ask questions. Participate in your classes and ask a question. Don't be afraid to. And yeah, that's the next one for our little promise throughout the week. But thanks again to the mechanical engineering team for presenting and helping us build our activity today. And thank you so much for that, because without you guys, I wouldn't be able to have this camp be as fun as it can be with the activities and the presentations and the information you have given them today. So thank you so much. I couldn't have done this without you. And again, I couldn't have done it without the campers and parents either. So thank you again for being a part of this and joining the camp every day. And I'm very excited to see you guys tomorrow. Sorry, it ran over again. We're trying our best, but hey, more time to have fun. But thanks again for joining. And I hope you guys have a great day and have fun with your challenges, improve, post them on the Facebook group. But I'll see you guys later, either at the help desk or tomorrow for day 3 of camp. Thank you all.